Hello everyone and welcome. Today we are doing more science. We're actually continuing with our theme of sinking and floating and discovering what we know about buoyancy. In this week's video, we are discovering how much weight it would take before an item that is buoyant becomes unbuoyant, or before something that does float sinks. For this experiment, you will need a place to store a lot of water. Again, I'm using a basin, but you can use a sink, bath, or anything at all, as long as a lot of water can be stored in it. I then have 4 12cm by 12cm pieces of tinfoil that I have cut. If you are doing this at home, I recommend getting a grown-up to cut it out or be supervised, because I don't want you to get hurt doing a fun experiment. The last thing you'll need is coins to put into or onto the pieces of tinfoil. Now I'm using 5 pences, but you can use any coin as long as you use the same coin for the whole experiment. What do I mean by that? So I'm using only 5 pences. That way I can say it takes blank amount of 5 pences before a piece of tinfoil sinks. If you say use 5 pence, then a 10 pence, then a pound coin, then a 50 pence piece, it doesn't give you an accurate or a fair representation of the weight. If you use the same coin over and over again, you know exactly how similar or different the weight is between the different pieces of tinfoil. For my pieces of tinfoil, I have done nothing to one of them. I've left that as a blank square, and if you lay that on the top of the water, it does float. I then scrunched one piece of tinfoil up by folded the edges of this a couple of times and scrunched the 2 ends up there. Another piece, I've simply just scrunched it up into a little metal ball, and for my last one I've been very careful and delicately folded each edge up, making it simply a slightly smaller square with its edges folded up. Now, I want you to answer the question, how many 5 pences will it take for each of these to sink? I'll give you a couple of choices. It can be less than 10 coins, between 10 and 20 coins, or more than 20 coins. Let's see, I'll start with the flat piece of tinfoil. So I'm going to delicately place that and let that float on the top. Super. And then going to take some 5 pences and let's get started. So remember, do you think it will take less than 10, between 10 and 20, or more than 25 pence coins before this piece of tinfoil will sink? I've got 10 5-pence coins on this piece of tinfoil and it has not sunk yet. So let's get our next set of 5-pence coins and see if it sinks. 1. Oh, I think it's going. I think it's, and that's it. It's sunk. So our answer to the first piece of tinfoil is it takes more than 10 but less than 20 coins to get it to sink. Now I've laid out a towel so that I can put my tinfoil and coins onto that and not ruin the table with water. I'm going to dry up these coins because again we want to make the experiment as fair as possible for each attempt. Now, just like last week, we were talking about an item's buoyancy, and I did mention a word density as well. If something's very dense, it has a lot packed inside, and then it becomes heavy and would sink. Again, this will float, and we're moving on to our second boat. Now remember, I folded the edges in and then scrunched up 2 of the sides. Let's see, will it be less than 10 coins, more than 10 or less than 20 coins, or will it be more than 20 coins before this will sink? Let's get started. So, 10 coins and it still stays afloat. 11, 12, 13, 13 coins. So, it didn't do much better than our flat piece of tinfoil. We could only get 2 more coins onto this boat. Now that's 2 of our experiments completed. It had taken 11 coins before our flat piece of tinfoil sunk to the bottom of the basin. And it had taken our folded then scrunched piece of tinfoil 13. So it did a little bit better, but not a lot better. Let's see how our next one fares. Now this I just scrunched up the sides to make a little metal bowl. So again, we'll leave that to float. And let's get started. Now again, will it take less than 10 coins, between 10 and 20 coins, or more than 20 coins before this sinks? Let's find out. So that's 10 coins so far. Oh! And with 10 coins, it's already filling with water. It's not sunk yet though. Just move you back in. Or is it about to sink? There we are. It's sunk now. So it's taken exactly 10 coins before that sunk. So actually, scrunching it up into a little bowl was worse than just leaving it as a flat piece of tinfoil. Now, there is a reason behind this which we'll go over at the end. So that's 3 of our experiments completed. In our first experiment, we discovered that a flat piece of tinfoil could take 11 coins before it sunk. In our second experiment, when we folded 2 edges and scrunched 2 edges, it would take 13 coins. And in our last experiment, it takes 10 coins before a scrunched up metal bowl would sink. Let's take a look at our last one. So I've delicately folded the edges 1 time to try and keep it as square as possible. So we'll leave that to float. And let's get started. So we have 10. It can get to 10 and it doesn't look like it's sinking yet. 18, 19, 20. We have got to 20 coins and this is still floating. And it doesn't look like it's sinking anytime soon. But let's find out. So we're at 21, 22, 23, 29, 30. 30 coins, and it's not sunk yet. So if you guessed that this would take more than 20 coins before it would sink, well done, you've got that one right. But let's keep going. Let's see if it could take all of our coins, all 50 of them. So 31, 32, 37, 38, and I just dropped the coin into the water instead of the floating tin foil. 39, I'll fish this coin out. Dry it off. 40 coins. We have 40 coins in this tin foil and it's still not sunk. Let's try our last 10 coins and see if the tin foil will sink in this turn. 41, 42, 43, 44, and there we go. 44 coins before that piece of tin foil sunk. Now, we have done 4 experiments and we've got 4 different answers. What made our last piece of tinfoil float for longer than the other pieces? Well, it focuses on areas of surface tension and weight. In our first and last experiment, there was a lot of space you could cover the coins with. So as long as you weren't placing the coins in the centre of the tinfoil each time, actually it would stay afloat for a lot longer. You're not breaking the surface tension of the water. In our second and third experiment, however, because there isn't as much space to put the coins end up being a very heavy weight in the middle. And that's why they sunk a lot faster than we expect. All 4 pieces of these tinfoil float. All 4 of them without any weight can float. Only a little bit of manipulation and changing to that can change dramatically how long it can stay afloat for before it will sink. Let me know the experiments that you did to see if your boats look anything like mine. Try it with other shapes and see what happens. And I can't wait to see all of this in the comments below. And as always, take care and enjoy the rest of your day. Bye!